Hello viewers, I am Dr. Neha Singh from ABES Engineering College, and today we are going to take the polymers topic, and in that we will specifically talk about polymer composites. What are polymer composites? Polymer composites is a material formed from the combination of two or more physically distinct phases having properties other than those of constituent materials. So what we do here, we mix a polymer along with some other phase. It may be a polymer, it may be a metal, it may be a ceramic, it may be carbon fibers. But what we do here, we do not let them blend together in such a way that both the materials, polymer as well as the other material, do not lose their identity. They maintain their identity and we can see them in the structure as well. So during the formation of composite, a synergistic force arises, which is responsible for the unique properties retained by the polymer composite as strength, toughness, high temperature, resistance, and lightweightedness. They are popular replacements for metals in mechanical industries these days. So have you seen the phone's transition, the mobile phone that we see whole today? It actually came out from a huge transition cycle. The initial mobile phones were very heavy because a lot of metal was being used over there. They were very big and a lot of functions were not there. Now we see our mobile phones are getting smaller every day. Even they can fit in our palms and they are very light. They are portable. They have a longevity and specifically they have cost effective with lot of functions around because most of the part of the mobile has been replaced by the composites instead of a metal, so which has made my mobile phone a lightweight polymer and a portable item, a very small concise item, and it increases the longevity because it has replaced metal which has a tendency to get corroded also. Now, we will talk about the composition of polymer composites. Polymer composites are of two types. They have two compositions, reinforcement and matrix. So solid part, extremely solid part is reinforcement, and matrix is a part which can be a bit of semi-solid or semi-liquid. So basically matrix makes the base in which the reinforcement is embossed. The reinforcement may be of the two types. It may be in a particle phase or it may be in a fiber phase. Particle phase is taken to increase the tensile strength, while the fiber phase is taken to increase the flexibility. Now, we will talk about the classification of the polymer composites, and there are two kinds of classifications. First classification is based on the basis of matrix. So on the basis of matrix, we can see the polymer composite are four types: polymer matrix composite, metal matrix composite, ceramic matrix composite, and carbon graphite matrix. So now we will elaborate them in detail. First, we will talk about polymer matrix composite. These polymer composites have matrix as their polymer. So when we will be making a polymer matrix composite, we will take any polymer, any desired polymer as a matrix. And here we can change, we can shuffle the choice of the reinforcement depending upon our requirement. Here also the selection of polymer may be thermoplastic or thermosetting depending upon the material we require. Thermosets are three-dimensional. They decompose instead of melting. So if we have the requirement that our polymer composite have higher molecular weight and they have high boiling melting point and they have high tensile strength, so they can be heat resistance. They can show the heat resistance. So we will pick up the thermosetting polymers. But if we want thermoplastics, which are flexible, they can be used for molding and remolding. So depending upon our choice of material, we will prefer the combination either of the thermoplastic or thermosetting material. So examples are, famous examples are E-glass, S-glass, carbon-carbon composites. Now the second kind of a classification is metal matrix composite. What we do here, when we compile this kind of a matrix composite, then we take any metal as a matrix. So and we can change the choice of the reinforcement. Metal and alloys form matrix phase here, and metals offer high strength, fracture toughness, and stiffness to composite. It also provides resistance against temperature and corrosive. The reinforcement material should be non-reactive in case of metal matrix composite, and it may bring about the undesirable qualities in composite. We know that metals are reactive, so here we have to be careful about the choice of the reinforcement we take, because it should be inert in nature. It should not be reactive with our metal. Therefore, in case it reacts to each other, it will give a different kind of a compound which we are not looking forward to. When more than one metal is used, what we can do, we can take a mixture of metal also. In case of one metal, we can take two metals, and then we can use the reinforcement. This kind of a composite is known as hybrid composite. The wonderful example of this is carbon fibers in aluminum matrix. This metal matrix composite is used in making the aerodynamical vehicles, as in space vehicles, aerospace vehicles. Now, third one is ceramic matrix composite. These composites have ceramics as their matrix. Ceramics are the compounds which have wonderful ability of exhibiting ionic as well as covalent bond. Because of this, they have high temperature resistance, corrosion resistance, and higher compressive strength. Though due to high modulus of elasticity and fragility they give, and higher thermal expansion coefficient of ceramics, these result into formation of weaker composites. So the examples are composite having alumina, silica, and mullite in the matrix. Now, fourth type of metal matrix composite is carbon graphite matrix composite. These composite possess carbon as its matrix phase along with the carbon fiber reinforcement. Here, high modulus, high strength reinforcements are incorporated in a low modulus continuous matrix phase. We can take graphite or fullerene, or we can take graphene as well here as a matrix. These help in construction of complex geometry in such a way that the different load carrying fibers can be oriented in specified directions to accommodate design's load of final structure. These composites render lightweightedness, exceptional stiffness, and strength to the material. These have vital environmental application, also used in aircraft and high performance vehicles. Now we will classify the polymer on the basis of reinforcement. Now we have seen there are two types of reinforcement we take. The first is the fiber reinforcement. So in case we take any metal, any polymer matrix which can be drawn into the fiber, it will be known as fiber reinforcement matrix. Fiber with shorter length provides high tensile strength, while long fiber retain the elasticity of the composite. The famous examples are glass fibers and carbon fiber composite. Second type is particular or particle reinforcement composite. These composite bear particles in the reinforcement phase. Particles may be form of flakes, powder. Since it is not homogeneous, the material properties acquire sensitivity to the constituent particles. So we have to see here the properties and geometrical shapes of the array, and also look up to the fact that the reactivity should be nominal or the least. Third type is laminar composites. These composites comprise a layer of materials held together by matrix. The most famous of it is sandwich panel, which is used in the fabrication material. So the polymer composite are like sandwich, means they have two different layers of for polymer matrix, and they are sandwiching a core material between them. The core material is lightweighted and have low distributing abilities and high corrosion resistance. It's having a honeycomb-like structure. As the thickness of core increases, stiffness is enhanced. These are used in aircraft, automobiles, and fabrication of roof and wall ships, etc. You can see this is the uh, composition of the sandwich panel. These are the face sheets which form the sandwich kind of a structure, and this is a core which is perforated. So this was all about the polymer composites. And application include formation of many medical devices, including MRI scanners, X-ray couches, wheelchairs, prosthetics. They are used in corrosive environment like salt water, piping, and ductwork. These are the references, sources. You can find all these things we have talked about in these reference books. Thank you so much.